Hi, Elijah. All right, guys. Well, thank you so much for joining me on this wonderful Monday morning. I want to go ahead and what we're going to do today is we're actually going to start our unit review. So we're going to see how many problems we can get through on this review in our 45 minutes together. Because you have a unit test this week. So part of it is 10 questions, multiple choice in the course. The other part is going to be in class kick, and I actually just opened it. And so we're going to kind of work through just a bunch of problems that are going to be on your test, both parts of the test. So if you have any questions at all, please stop me. I want to make sure that I'm going slow enough that you get to understand, and then, but fast enough that I'm not just telling you things you already know. Hey, Jonathan. Alrighty, so let's start with this review. I'm going to do this first slide, and then y'all will do the second one. So this says for each function, evaluate f of -2, 1.5, and f of -4. And so those were already on there, but how do we find f of -2? So remember that this f of is really f of x. Okay, so we want to know when we plug in a number for x, in this one it's going to be -2. So when f of -2, that means when x is -2, let's go to -2, we're asking ourselves, what is that y value? And that y value would be 0. Okay, so if I write this out, or I'll just type it for you here. This is saying when x is -2, what is the y value? Okay, that's what that one means. Okay, so then this next one is going to mean when x is 1.5, what is the y value? So when x is 1.5, so I'm going to come over here. This would be 1, this would be 2. So somewhere in between, okay? And we go over, what is that y value? It would be 1. Let me write that in red. 1. All right, and then lastly, we have when x is -4, so we're going to come over here to -4, that's right here. We go up till we hit that point. What is that y value? It is also 1. Okay. All right, any questions about how I did any of those? All right, then I would like for you to try these. So we'll call this one number 1, 2, and 3. So you can just put in your numbers for 1, 2, and 3. Good, Elijah. Good, Jonathan. Alrighty, so let's go ahead and look at f of 1. So this means when x is 1, y equals, and that point is going to be right here, which is going to be 5. The next one is when x is 0, what is our y value? So when x is 0, our function is right here, and that would be 3. And then lastly, when x is -2, which would be right here, we're going to go up till we hit that function. That y value is +2. Good. Okay. Give me, how are you feeling about these? Evaluating functions on a graph. Okay, awesome. So let's just do a quick review here. For function notation, y is the same thing as f of x. Okay, so when we say f of x equals a value, let's say we said f of x equals 1, that's the same thing as y equals 1. F is just the name of the function. So if we go over the parts of this f is the name of the function, and then x is going to be our input. Okay, so when we put in a number for x, we get out another number, which is y, or our output. Okay, we commonly call functions by letters. Okay, function starts with an f, so we say f of. Sometimes it's like g of, h of, but we normally will see f. The green f, I have it circled in green. This means the right-hand side of the function over here is called f. This parentheses and the x in the middle, this means that the function on the right-hand side has the variable x in it. Okay, this does not mean that we're multiplying f times x. Okay, this is the function of x. Okay, so the left-hand side of the equation is called function notation. It tells us two things: what the function is called, this one is called f, and the variable that's going to be in the function, which in this case is x. As you can see, we have 2x squared minus 3x. So remember that whatever's on the left-hand side, that tells you what you're going to do on the right-hand side. For example, this is f of x, so that means there's an x over here in this function. F of 2 means anywhere there was an x, I'm now going to plug in the number 2. So f of 2 is 2 times 2 squared minus 3 times 2 plus 6. And what we're going to do is I want you to just get in the habit of always putting these in your calculator. There's two ways you can do this. I'm going to pull up my calculator. So if you have a calculator, go ahead and get it out. Or if you use a calculator on your computer, that's fine. I'm going to go ahead and let's see. I need to screen share. I'm going to screen share on this side. All right, so I'm going to go ahead and open up my calculator. All righty. So, alrighty. Now, remember that our equation, the function, was 2x squared minus 3x plus 6. Okay, so if I come over here now, I'm going to do 2, and then in parentheses, I plug in whatever my x is. So 2x squared minus 3 times 2. Whatever I'm plugging in, I put it in parentheses, plus 6. Then I'm just going to hit my enter sign. Okay, and that tells me it equals 8. Another way you can do this is go to y equals. I'm going to clear out both of these functions here. All right, so I'm going to type in my original function. So that was 2x squared minus 3x plus 6. Now, what I'm going to do is I'm going to hit the second button and then the button that says graph. So that's going to bring up a table for me. By using this table, I can say, okay, when x is 0, y is 6. Okay, so I can put in a bunch of different values, but I wanted to know when x is 2, what is y? Again, it's 8. So there's two ways you can do functions, evaluating functions on your calculator. All right, I'm going to stop my screen share. Let's go back to our slides. Alrighty, so now what I want you to do is we have our original function, 2x squared minus 3x plus 6. This is the same equation or function we had last slide, but now we are going to be finding f of negative 2. So what does f of negative 2 mean? This means instead of having an x in our function, anywhere we had an x, we're going to put in a negative 2. Okay, so I want you to go ahead, put in a negative 2 everywhere you had an x. And I want you to put that in your calculator to solve it. So we're going to find out what is the function, what is y when x is negative 2. All right, did anybody get a number for f of negative 2 yet? Anybody? No, not quite. So did y'all put it in your calculator? Did you just plug it in the calculator? Okay, good, Brianna, good, Angel. So if you're plugging it in the calculator, make sure you put everything in parentheses that needs to be in parentheses. And also remember to use the negative sign, which is under the 3, not the minus sign when you plug in a negative 2. I'm going to try anyway, so take a little screenshot and show you exactly how you're supposed to plug it in and what you will get. Let's see if it will let me paste it on here. Oh, it's not letting me. Okay. I'm going to go to the whiteboard real quick. All right. And okay. So when you plug this in to your calculator, you have 2, and then in parentheses, you're going to use the negative button, not the minus button. Negative 2 squared minus 3 times negative 2 plus 6. And that is how you will get 20. Any questions about how I got there? If you're having trouble putting it in your calculator, that's okay. Just let me know. So, alrighty. So, this says which function equation matches the table. So we have this table. And we want to know when I use this number 0 for x and plug it in over here, when will I get 0 for my y? So let's go ahead and just try them out. So we'll say we have A, B, and C. So for A, I get 3.5 times 0, which is 0. So far A works. For B, I get 5 times 0 plus 1. So that would be 1. So we know that B cannot be it. For C, I get 2.5 times 0, which is 0. So far, that one works also. So now let's plug in 1. So we got 3.5 times 1 is going to equal 3.5. But we were wanting 2.5. So then obviously you can see that C is the correct answer. This question down here, given the table of values, what is the value of f of 3? So when x equals 3, what is y? Look at your table. When x is 3, y is 7.5. Questions about that? All right. So a function is a set of ordered pairs of numbers, x comma y, such that no x values are repeated. So what that means is a function is only a function if it has x values that do not repeat. Okay, so can y'all tell me what are the domain and range of a function? What does domain represent? What does range represent? Anybody? Okay, good, Nevaeh. So the domain is the set of all x values. Very good. Good, Jonathan. And the range is the set of all y values. Very good. So domain and range of a function are sets that describe the ordered pairs. So another way to describe domain and range, domain is the set of the first coordinates, okay, so the x values. Range is the set of the second coordinates, or the y values. So for instance, if this is our function here, our domain is going to be all the x values. So 3, 2, and 5. Our range is going to be all the y values. So 6, 8, and 3. All right, another way to describe this is the domain is the set of all the values of the independent variable x. So we're talking about numbers that are moving left and right. The range is going to be going up and down. Those are the y values. So I want you to tell me on this one, what is the domain and what is the range? Good. Okay, good. So domain, exactly. When we write out our sets, we're going to use these squiggly brackets. So domain is 2, 4, 6, and 8. Very good. And range is 7, 11, 15, and 19. Okay. Another way to represent a function or a relation is called a mapping. So our domain is going to be the set of all x's, okay? And they're going to pair with exactly one y value, okay? If any of your numbers in the x column repeat, it's not a function, or if you have two arrows coming from an x value, it is not a function, okay? So let's do a multiple choice question. What is the domain of this relation? And this is a relation because we have repeating 4s in the x's. Okay, so this is just a relation. This is not a function, but you can still tell me what is the domain. Good. So the domain, if I go through and highlight, we've got 2, 4, 3, 4. And then if I want to write those from smallest to biggest, since that's how they'll appear on my answer choices, 2, 3, 4, 4, which is number 1, or A. Very good. All right. Now, can you tell me what is the range of this function? Sorry, this relation. Good. So the range, the domain is, yeah, you could write it as 1 or 3. Yeah, sometimes it will repeat, sometimes it doesn't. So yes, it could be 1 or 3. Yes, Angel. Okay, so then for the range, if I highlight my y values, 1, 2, 3, 1, we could either have 2 or just 1, 2, 3. Okay, so it could be written one of two ways. Very good. Okay, so I am looking for a few volunteers. If anybody wants to, I'll do the first one real quick, and then I'll need 2 volunteers. So for the first one, the first thing I'm going to do is list out the domain. So my domain is 3, 4, 5, 6. And my range is 2, 4, 6. So now I'm going to ask myself, is this a function? Do I have any x's in this column that repeat? No. Do I have two lines coming from any of the numbers? No. So this one is a function. All right. Do I have two volunteers that would like to try one of the next two? Anybody? Okay, Angel, I'm going to have you do this one. Anybody else want to try? Okay, awesome. Elijah, I'm going to have you try the last one. Is that okay? All righty. So if you are not doing this on the board, so if you're not Angel and you're not Elijah, go ahead and work on this on your own paper, okay? Good, Angel. So for Angel's domain, everywhere that we have a point, we're going to write out the x values for that. Okay, so she wrote out -3, -2, 0, 1, 2, and 4. Great job. And as you can tell, we don't have any repeating x values, so it is a function. And now she's just going to write out the y values. So she's going to go back to all these points and write out the y values. For Elijah's, the domain, let's look here, Elijah, real quick. You're close. So for the domain, we want to use our vertical lines here. So at that point, and then at x is that point. Whoopsies. So it looks like that might be -4.5. And since this is a continuous function, this is where we're going to use our inequality. And then that looks like it goes to about 8.5. So then for the range, we're going to use that inequality again. So go ahead and find the lowest value, which would be about here, and the highest value. You can just kind of guess on the decimal. Good, Angel. Great job on the range. Very good. Good. So we're going to go from -2 to, yeah, about 6. Or if we wanted to, since we know it doesn't go quite to 6, we could say something like 5.8 or something. And you're right, it is not a function. Exactly. Good job. All righty. Now let's see. Let's go ahead and find the domain and range of this graph. And what I'm going to do is add a very important piece. Good, Jonathan. So when I added the arrows, the domain becomes all real numbers. Exactly. All real numbers. And my range, what does it look like my range is going to be? Not quite. So first of all, for the range, let's find our lowest value. So it's going to be right here. What is that y value? That y value, it's not -1 because -1 is down here. So you're telling me the x value, but we want to know what is the y value. Good, Richard. So this is at 0. Okay. So my lowest value is at y equals 0. And then when I get to the top, that goes on to infinity. So my range is going to be all y values greater than or equal to 0. Yeah, that's okay. That's why domain and range isn't really that hard. But it is hard in the fact that it's easy to get tripped up. All right, let's go ahead and try these. Alrighty, so for this first one, because our endpoints are arrows, we know that that domain is going to be all real numbers. So now we want to look at the range. So here's my lowest value, and that's going to be at -7. So our range is going to be all values for y that are greater than or equal to, good, -7. All right, for this one on the right, I want to make you aware that with our domain, okay, so if we go to the far left endpoint and the far right, they both have arrows. So domain is all real numbers, and for range, our lowest endpoint keeps going to -infinity, and our highest endpoint keeps going. Yeah, so this one, the domain and the range, are going to be all real numbers. Okay, let's look at, that one's kind of hard to see. Alrighty, I want to give you some tougher ones. So these are going to be intervals now for your domain and your range. So go ahead and work on this first one. We'll call it number 1. So tell me what the domain is, and then tell me what the range is. All right, so the domain for the first one, I'm going to go to my far left point. Let me put that in green here. Okay, that point is at -2, but it's an open circle. So when I write this domain, I'm going to just use the less than sign. Now, whenever I come to the far right side, that is a closed circle, and that is at the x value of 6. Since it's a closed circle, I'm going to use my less than or equal to sign. Any questions about the domain? All right, so now let's look at the range. Again, I'm going to go to my range. We're going to start at the bottom. That is at the y value of -4. So I'm going to come over here. My range is going to be -4. That's a closed circle, so it's going to be my less than or equal to. Range is for y values. And then I'm going to come to my top point, which is at the y value of 2. Since it's an open circle, we're going to do strictly less than 2. Okay, let's look at number 2. So for our domain, here's our far left point. It's an open circle. So that's going to mean we're going from -5, strictly less than sign. Okay, so x has to be greater than -5, but less than 7. We're not using any less than or equal to signs because both endpoints are open circles. All right, now I'm going to come to my range. So my lowest point is at -6. And that is part of the function, which is continuous. So that is going to be a less than or equal to sign. Then I have y values. My highest point is at 8. And that is going to be strictly less than because that point is an open circle. Excuse me. Okay, I want to do a few multiple choice problems with you. Actually, we've done that one in class, so let's do this one. What is the domain of this function? Remember, domain is x values. That's okay, Richard. So we know it cannot be D because that has a Y in it, and we are wanting domain, which is x values. So let's find our farthest left. It's a closed circle at -1. So that eliminates C. Farthest right is a closed circle at 5. So A is the correct answer. Good job, guys. All right.
But that's when I misconnect.
That's okay, no problem. All right, this will be the last one we do today, and then I'm going to send you to go work on your assignments if you have not done them yet. So I'm going to put up the poll, and while I'm doing that, I'm going to pull up the grade book as well so I can help y'all know what it is you need to go do. So we're looking at domain, okay? Domain, which is x values. Okay, I only have 4 answers so far. Oh, I got 5. Okay. So remember, it cannot, guys, we're looking at domain. It cannot be C because that has a Y in it, and it cannot be A. Okay, so let's take a look here. Domain is X values. So here's my farthest point to the left. That's at -2. Okay, so automatically we eliminate B as well. Okay, so -2. It's strictly less than because it's an open circle. My farthest point to the right is at 6 and it's colored in. So D is the correct answer.